So let's quickly go through this worked example. It says calculate the vapor pressure lowering when 10 blah blah blah. So anyway, we know that when we're talking about vapor pressure lowering, we're talking about these two formulas. The first one, vapor pressure lowering. This is going to be the molar fraction of the solid times the initial vapor pressure of the solvent. Okay, the pure solvent, the solvent without any solution. And then we also know that vapor pressure lowering is going to be the initial pressure of the solvent minus the final pressure of that solvent. So it's now the pressure of the solution. Why? Because it's lowering. So it's lowering, so that means the final will be less. So we always put it last because we always want our answers positive. So these are the two formulas that we're going to be using. Either way, the first one is going to be this one. That's the one we use. So let's go for it. For us to use it, we need to find this x. And for us to get the x, we need to first find the number of moles of each of the guys. So what do we have here? We have glycerol. And what did they give us? They gave us milliliters. Remember, this is a small m, which is milli. This is liters. So milliliters, this is volume. They've given us volume, okay, of glycerol is added to, here they've given us volume of water again. The vapor pressure is blah. The density now, here they've given us the density, and its density, that's pure water, is this, and the density of glycerol is this. So either way, I have density, I have volume. What formula do I know that it's this? Density is equal to mass over volume. I want the mass because I know that number of moles is equal to mass over molecular mass. So I want the mass. So I'm going to take volume to the other side. I'll say density times volume. Okay. Density times volume is equal to the mass. So you can write it that you're now writing the solution. This you would have written with a pencil, right? So you're now writing density times volume is equal to the mass. So now you can say, what is the density for glycerol? 1.26 grams per milliliter times what's the volume? 10.0 milliliters. This should be giving me my mass. Now I can say my mass would be 12.6 grams because the milliliter and the milliliter, it's per milliliter and milliliter, they'll cancel and I'll get my mass, 12.6 grams. Then I can get again the mass for the water again. I'll need the number of moles of water. So I would say, what is the density of water? 0.988 grams per milliliter. So I'll skip a line. I'll say 0.988 grams per mil times what is the volume? The volume of water is 500 milliliters. So times 500 milliliters. This should give me the mass. All right, so let's go for it. 0.988 times 500. It's 494. So I'll get 494 mils. This should give me the mass. Okay, so now I have these two. I have the masses. What should I go ahead and do now that I have the mass of the glycerol? This is the mass of glycerol. And then here we have the mass of water. So now I can go and say number of moles of glycerol. We can first just say number of moles is equal to mass over mR, which means the number of moles of glycerol is going to be the mass in grams, always in grams, 12.6 grams over the mR of glycerol. Do we have the mR of glycerol? We go back to our question. Glycerol is C3H8O3. C3, that means it is 12 by 3. So it is 3 carbons, so 3 by 12, plus H8, which is 8 of hydrogens by 1, plus, is it O3, which is 3 16s, okay? You get it in the periodic table. You just look at your periodic table. You are going to see these masses that I'm putting. For oxygen, it's 16, the bigger number there. That's your mass. And remember, this is grams per mole. Okay, this is grams per mole. Whenever we see grams per mole, we know we have the molecular mass, the mass that we get if we look at the periodic table. So I can get the number of moles. Let me skip a line. Let me first come here and say number of moles of water would be, what is the mass Why did I, sorry, it's not, this is grams. This is grams. 494 grams. So it's going to be 494 grams over what is the molecular mass of water. Of water, we know that it is H2O, which means 2 hydrogens, 2 by 1, plus an oxygen, which is 16. It will give us a total of 18, okay? So either way, let's get the values now. So I would have this as, this is going to be 12.6 grams over, we can put the total if you want. So it's going to be 12 by 3, okay? And then plus, open bracket, 8 times 1, which is just 8, okay? Then plus, open my bracket, say 3 by 16. Close. This gives me 92, so over 92 grams per mole. Okay? And here I have it as 494 grams over 18 grams per mole, right? These are grams per mole. This would give me what? So I would first say 12.6 divided by 92. I would get whatever, 0.13695. So 13696. Okay, I'll end here. These would be moles. Then here I'll say 494 divided by 18. What would I end up getting? Here I'll get 27.4444444. So I can just say 27.4. Here I can round off to 3 as if I want to make this, what did I have? 0.1369. So it becomes 0.137. So I'd have it as 0.137 moles here. Either way, now that we have the moles, we can now get the X. So what do we want? We want the X of the solid, which is glycerol. So X of glycerol, our solid, because that's the one we are going to use to find the vapor pressure lowering. This is going to be number of moles of glycerol, okay, of glycerol over the total, which is number of moles of glycerol, plus the number of moles of water, okay? Please, you're not allowed to cancel them, to say this cancels with this. There's an addition sign that you cannot ignore there. So here, glycerol, what does it say? It is going to be 0.137 moles. Then divided by, in here we say 27.4, or we say 0.137 moles, or plus, sorry, 27.4. We can put the moles outside to say moles. Then here, what would we get? So 27.4 plus 0.137, we will get an answer. Then we say 0.137 divided by that solution. We'll get 0.00497. 0.00497. And here we don't have a unit. Now we can say our vapor pressure lowering, delta P, is equal to X solid, which is glycerol, times the solvent, times the vapor pressure of the solvent itself, which is water, okay, of the initial vapor pressure of the solvent. Remember that it is the initial, that's why we put the 0, the water. So it's going to be 0.00497 times what is the initial vapor pressure of the water. The vapor pressure of pure water is 92.5 torr. So we would have it as multiplying 92.5 this was 49 here. So now 92.5 torr. Say torr. Then we can get it. So I'll say this times 92.5. We will get 0.459. 0.4. Let's see. This becomes 0.459 torr. Okay. 0.459 torr, and this would be our final solution. All right. Exactly. So This would be your final solution for your vapor pressure lowering, and you put the torr, because this wasn't torr, this would be in torr, and you're done.